Hello students, this is the basic lecture how to convert a keto form into its enol form, which is very important for understanding tautomerism. See, in the first compound, this is the keto form. I have to convert it into enol form. See, there are six alpha hydrogens. CH3 is on this side, CH3 is on this side. So alpha hydrogen can migrate from both directions. It can migrate from this direction, it can migrate from this direction. Let me migrate the alpha hydrogen from this direction. So the compound formed will be an enolic form. The double bond O will convert into an enolic form OH, enolic form OH, and a double bond will come here and a double bond will come here. So this will be the enolic form because of migration of hydrogen from this. There is also another possibility. The hydrogen can also migrate from here and the compound will be like that. If the hydrogen migrates from there, it will be an OH, it will be an enolic compound, and the double bond will come here. So this is the keto form. There are two possible enol forms. The first enol form is the structure number 1 and the second enolic form is the second structure number 2, because this compound contains 6 alpha hydrogens. Coming to the question number 2. See, here the possibility is that hydrogen does not get migrate from the terminal position. Rather than hydrogen gets migrated from this position, hydrogen gets migrated from this position. So the enolic form, it can get migrated to this position or it can get migrated to this position, but it never gets migrated from this position, because the compound which is formed, the enolic compound which is formed is like this. Usually if the hydrogen gets migrated from the central position, and the double bond will come there, there. Or we can also have a second structure. The hydrogen can get migrated from here and we can have a second structure like this, the enolic form like this. From here it will be double bond O, and it will be here, the double bond will come here, and it will this will be, these are the two enolic forms of this structure, of this keto form. Now coming to question number 3. There are alpha hydrogens are present on this, and alpha hydrogens are present on this carbon. Here it's CH2, here it's CH2. So the hydrogen can get migrated from this position to here, or it can get migrated from this position. So if the possible enolic structures will be like this. Here it will be OH and the double bond will be here. If it gets migrated from here, the enolic structure will be like this. The enolic structure, it will get converted into OH, and enolic structure will be like this, and in this case there are only 3 alpha hydrogens. So alpha hydrogen has to get migrated from this position. So the enolic structure of this will be, so the enolic structure will be like this. It will get converted in double bond O will get converted into OH, hydrogen will be here, and double bond will get shifted here. Because hydrogens, there are 3 alpha hydrogens, so usually one hydrogen will get migrated here and it will get converted into keto form. Coming to these structures, the enolic form of this structure will be like that. It will be an aromatic structure because of presence of 3 alternate double bonds. So here, if it gets mostly shifted from here, or if gets mostly shifted from here, so the double bond will come here. Here also double bond O will get converted into here OH, and the double bond will come here if it gets migrated from here. If it gets migrated from here, it will form a structure OH, and the double bond will come here. So this is an aromatic structure. This is the enolic form of this structure. This is the enolic form. Coming to this, the enolic form will be like this, which will be highly unstable because of its anti-aromatic nature. So this will be the enolic form. Generally this structure will not get converted into enolic form because the structure which is formed is anti-aromatic in nature, which is highly unstable. So this structure does not get converted into enolic form. Coming to this question number 7, the enolic form will be like this. The alpha hydrogens can get migrated from here, or alpha hydrogens can get migrated from here. If they get migrated from here, the enolic form will be like this. The enolic and double bond will come here. Or if they get migrated from here, the enolic form will be like this. OH, and double bond will come here. So these are the 2 possible enolic structure of this compound. Now coming to Coming to question number 8. In this case, usually the hydrogen gets the alpha hydrogens get migrated from this position, so the enolic structure will be like this. Enolic structure will be like this, and it will get converted into OH, and double bond will come here, double bond will come here. This will be pH phenylic ring, this will be pH phenylic ring. Usually it will form a hydrogen bond, this which will add a stabilization to enolic form. In this case, the enolic form will be far greater than its keto form because of this hydrogen bond and because of the resonance given by these two this phenylic group, because this double bond will be in conjugation with the ring. So in this, the enol form will be much stable as compared to keto form. Now coming to question number 10, which is a classical example of tautomerism. Since alpha hydrogens cannot get migrated from this position and this position, they usually get migrated from this position. It's a classical example of what is known as tautomerism. So the enolic form will be the enolic form will be like this. Enolic form will be like this. The nitrogen will be here, the nitrogen will be here. This hydrogen will get migrated and it will convert into OH, and there will be alternate double and single bond, making the structure as aromatic. And aromatic structure, generally when enol form is having an aromatic structure, it's more stable. Thank These were the some of the questions on keto enol, on the keto enol isomerism, how to convert a keto form into an enol form. I'll repeat. In the question number 1, I have shifted the alpha hydrogens from both the positions, giving two enolic form, first one and second one, which is the enolic form. Here the hydrogen gets usually shifted from this position rather than these positions. It's least likely to get shifted from these positions. They get usually pushed on, and the enolic form will be this. In this, there are two alpha hydrogens, so the alpha hydrogens will get migrated from this position, forming OH. In here, the alpha hydrogens will get migrated from this position, forming an enolic structure like this. In this, the alpha hydrogens will get migrated from this position, forming an aromatic enolic structure. This form generally does not give a keto form, because the enolic form which it forms is highly unstable due to its anti-aromatic nature. Here there are two possibilities. The alpha hydrogen can get migrated from this position, or alpha hydrogen can get migrated, giving two enolic structures are possible, with the double bond here and a double bond here with OH groups. And in this case, the alpha hydrogen usually gets migrated from here, and here the enol form is much stable because of presence of hydrogen bond, and the two phenyl rings stabilize this with the keto form. And coming to the question number 10, the hydrogen gets usually migrated from the para position. It's a classical example of tautomerism, forming an aromatic enolic compound. The 3-4 things which give stability to the aromatic nature of the enolic compounds are hydrogen bonding, aromatic nature, steric hindrance, and the solvent which is used.